Hello students, welcome to Adankal. Good evening to all.
Good evening, sir.
Good evening, sir.
Good evening everyone.
Good evening, sir.
Good evening Amit.
Good evening, sir.
Good evening Satish, Yashri. First topic for today is Brillouin zone. Brillouin zone, and in fact we will be drawing the Brillouin zone for 1D and 2D lattices. And then we will see the shape of those Brillouin zones. Now, first of all, the definition of Brillouin zone. A Brillouin zone, why it is important to us, this will be clear from this definition, is the locus of all those k values. K means wave vector, that is 2 pi by lambda, okay, in the reciprocal lattice, which satisfies the Bragg condition. Bragg condition. And what is the Bragg condition in reciprocal lattice? This is the Bragg condition, where our k vector is of the form kxi cap, kyj cap, kz cap, and g vector is of the form ha plus kb plus lc, where abc are the reciprocal lattice vector, with abc as reciprocal lattice vectors. So this is the definition. And locus means the shape formed by those k points which are satisfying this Bragg equation. If you keep on joining those points, those k points, then you will get a shape which is called Brillouin zone. That is what we mean by locus. Okay, clear? Is the definition clear to all?
Can you repeat, sir?
We have to find those k values which satisfy this equation. This k is different. Let's call this k. So I'm using different symbol for wave vector, okay, because there is another k also corresponding to Miller indices. So let's change the symbol for wave vector. This k is the wave vector, which is 2 pi by lambda. Okay, so we have to find the k values which satisfy this equation. So obviously, as we say that in direct lattice, only certain lambda values they satisfy 2d sin theta equal to n lambda equation, isn't it?
Yes, sir.
We write 2d sin theta equal to n lambda. Then all the lambdas they do not satisfy this equation. Now only certain lambdas, and because k is equal to 2 pi by lambda, so if only certain lambdas they satisfy this equation, so it means only certain k's will obey this equation. One and the same thing, na?
Yes, sir.
That is the Bragg equation in reciprocal lattice, yari. This is the Bragg equation in reciprocal lattice. Bragg condition in reciprocal lattice. This 2k dot g plus g square. Okay. Just as you have this Bragg condition for direct lattice, for reciprocal lattice we use this Bragg condition. So now by knowing those k values, I keep on plotting those k points. Suppose I'm plotting like this, then you will join these points. So then the shape that you will be getting, I'm just giving you an example. Of course, you are not going to get this kind of shape. Then by joining those points together, the shape that we will be getting, that will be referred to as the shape of the Brillouin zone. Now clear? Okay, any doubt? Any doubt regarding the definition?
No, sir.
Now let us find the Brillouin zone for 1D lattice first of all. But for that you need to know the little bit history, how we calculated the reciprocal lattice vector for simple cubic lattice. And here because it is 1D, so only one of the vectors we need to find. So you need to know a little bit about this. Let me use the lighter one so that you're able to identify what is happening. So these are the atoms, okay? These are the atom positions in reciprocal lattice, that is kx, because we are discussing the 1D case, na? So let it be kx, or simply you can take it to be k also, because in 1D either you can write kx or k, it doesn't matter. Now if I take this as the reference one, reference means kx is 0 over here, then what will be the k value at this atom, which is adjacent to it and at the right side of it? If the spacing in the direct lattice is 8, then what is this value according to you?
2 pi by 8.
Very good, 2 pi by. So that's what we calculated in simple cubic, and this will be minus 2 pi by. In simple cubic we took a vector as ai cap and we ended up getting a star as 2 pi by ai cap, isn't it? Do you remember?
Yes, sir.
And from there we know this fact that if the spacing between the atoms in the direct lattice is 8, then the spacing between the atoms in the reciprocal lattice is 2 pi by. Now you need to remember this thing, okay? So now what I have to do is I have to draw shortest reciprocal lattice vector. So now this will be 4 pi by, this will be 6 pi by, this will be minus 6 pi by. So what are the shortest reciprocal lattice vector? This will be the one and this. So there will be two reciprocal lattice vectors from origin to the nearest points, nearest atoms. Please see the diagram. These are the shortest vectors that you can draw from the reference to the atomic positions. Now what you have to do is you have to draw the perpendicular bisectors of these vectors. So the perpendicular bisector of this one will lie at this location, and this one will lie at this location, and this will be pi by a, this will be minus pi by, isn't it? Please check, everyone.
Yes, sir.
Because 0 to 2 pi by a bisector will be at pi by a, and 0 to minus 2 pi by the bisector will be midway, means minus pi by. So now this is the region of the first Brillouin zone. I mean, you can share this region now. This region. This is the first Brillouin zone. Now what about the second Brillouin zone? Now what are the next vectors that you can have. Next possible ones. Again from origin to next atom, this one. And from origin to next atom, this one. Now what about the bisector 0 to 4 pi by? Bisector will lie at 2 pi by. And here the bisector will lie at minus 2 pi by. Now the important thing, second Brillouin zone region is this much only. Excluding the region that was contained in first Brillouin zone. Obviously, when we have said that that particular region belongs to first Brillouin zone, so obviously that is the part of first Brillouin zone. Now we cannot include that region. Okay, we cannot include that region in the second Brillouin zone. Please, is it clear?
Yes, sir.
Can you repeat?
First Brillouin zone is clear, Shari? Or
Yes, sir.
Now, after the first Brillouin zone, what are the next possible lattice vectors that you can make? This one, now see clearly. This one,
Yes, sir. From
this one.
minus 4 pi by
Go
8.
to minus 4 pi by. And what will be the bisector? It will lie at minus 2 pi by.
Yes, sir.
And the next one will be this one, 0 to 4 pi by. And the bisector will lie at 2 pi by. So now the only that part of the region will be included, which is not contained in the first Brillouin zone. And that part is from minus 2 pi by to minus pi by and pi by to 2 pi by. It means this region is included in first Brillouin zone. This is first Brillouin zone part. And minus 2 pi by a to minus pi by and pi by a to 2 pi by. Second Brillouin zone. Am I right?
Yes, sir.
Now, if I go towards the next Brillouin zone, what will be the region corresponding to that Brillouin zone? Now you will tell me. Third Brillouin zone. Next possible vectors are these from 0 to minus 6 pi by and 0 to 6 pi by. And their bisectors, they will be at plus 3 pi by a and minus 3 pi by a. Na? Isn't it?
Yes, sir.
So now only this much region will be included, which is not a part of first and second Brillouin zone. This is the new region that we got. Na? Okay. Clear to all?
Yes, sir.
So what do you infer from all this that we have discussed?
They can intersect with each other.
No. It means first Brillouin zone is continuous. There is no gap in between. Whereas all other Brillouin zones are discontinuous. No, Arun. But here they are of equal widths, you can see. But in all the lattices, they are not. Here they are of equal widths, and each of them it is having the width 2 pi by if you calculate. Here you are right that they are of equal width. And in 2D square lattice also, they will be of equal area. But if it is the rectangular lattice, then of course again I think. But in real lattice it may be different. Okay? Clear? This question may be asked in the exam that the first Brillouin zone region is what? And the options they may be given. So everything clear about 1D lattice Brillouin zone? So you can also write that all the zones are of equal width in this specifically.
Sir, is there a number of zones possible?
Yes, you can go up to any number of zones. You can go on making, and this is obviously not going to end anywhere because the crystal lattice it is itself infinite. Okay. But we only need the information between the first Brillouin zone. That is important to us. If we know everything about the first Brillouin zone, then we are able to get the information about other zones also. Yes, Yari, because these are corresponding, these K values, they are corresponding to the Bragg condition. So obviously, they will provide you with the diffraction. Because the Bragg condition, it leads to the formation of these.
Sir, actually, I wanted to ask, like, whether in the first, in the Bragg condition, you said that it is kind of a negative statement. Like, it may give us the reflection that can happen. So, this condition, is it like that only, like negative? We make it, or like we can definitely get the diffraction at these zones?
No, it's not that. Bragg condition is still a negative statement. These K values, they may correspond to diffraction, but they may not also. You cannot strictly say that these K values, they will definitely go for the diffraction. It's not that. We can only say that at these K values, diffraction may be possible. Okay?
Yes, sir.
Because we can never predict what is going to happen. Huh? That is the thing, that what is going to happen in reality. Now, Brillouin zone for a 2D square lattice. So why I'm taking a square lattice? Because it is the easiest case, and later on I will tell you about the rectangular lattice also, that what will be the shape of the Brillouin zone if we have rectangular lattice instead of square lattice. But right now, making the things a little bit easier for you. So now, what are the direct lattice vectors for a 2D square lattice? Anyone?
AIK plus AJK.
AIK?
Plus AJK.
No, why should be plus? It is only AI cap and AJ cap. Just as you had in the simple cubic lattice, AI, AJ, AK.
Okay, sir.
Because it is 2D, so we are having only X and Y. So now the very first thing is we have to get G vector, and you know G vector is written as H A K D L C, and in order to get, and here G vector will be HA plus KB only because it is 2D. Na? So we need to get A vector and B vector first of all. That is reciprocal. So reciprocal lattice vectors are. Now can you tell me what are the reciprocal lattice vectors? Again, you need not write anything. You can straight away write these A vector and B vector. What are the values?
2 pi by A I cap.
Yes, we have already calculated for simple cubic. Na? From there you can straight away write by assuming let's C be K cap, and then you will be able to get A vector and B vector like this. Now, the general reciprocal lattice vector. So those were G vectors that we draw in case of 1D lattice. Na? Those were G vectors. Now you can put the values of A vector and B vector. This, please check. Is it?
Yeah.
Now what is K vector for 2D? It is Kx I cap, Ky j cap. K vector, V vector. So now you can put these values in the Bragg condition for reciprocal lattice. That is 2k dot g plus g square equal to 0. You will end up getting the condition for hk values or the kx ky values. Noted everyone from this slide? Yes, students, noted or not?
Yes, sir.
So Bragg condition for reciprocal lattices 2k dot g plus g square equal to 0, and this gives us 2 kx I cap ky j cap dot 2 pi by a hi plus kj plus g square, that is 2 pi by a square x square plus k square. Is it? Please check. So hkx plus kky, it will be minus pi by a. So you can call this equation as equation number 1. Please check.
Yes, sir.
Now, what are the least possible values of hk that we can have? Let us name it as case 1. Either we can have hs plus minus 1 k equal to 0, or we can have h0 k plus minus 1. In both the cases, we will end up getting h square plus this k. In both the cases, we will end up getting h square plus k square equal to 1, and this is the least possible value of x square plus k square. It cannot be less than this. Now, if I put h equal to plus minus 1, it will be like plus minus kx plus 0 ky equal to minus pi by. So this gives me kx equal to plus minus pi by, and ky can be anything. Anything means it is arbitrary because 0 into anything is 0. Please check. Similarly, if you put h equal to 0 and k equal to plus minus 1, you will end up getting kx as arbitrary. Arbitrary means there will be infinite possible values of kx and ky plus minus pi by. Please check. Yes, beta, please check.
Yes, sir.
So later on, we will be plotting these. These are the equations of the line. Na? So kx equal to pi by a will be one line. Kx equal to minus pi by a will be another line. So these are the 4 lines actually. So when we plot these 4 lines, they will intersect each other, and we will get a region which will belong to the first Brillouin zone. But we are going to draw these lines later on, after getting the region for the second and third Brillouin zone also. Okay. So we will be doing it together in the last. But first of all, is it clear about the first Brillouin zone?
Yes, sir.
Now, what are the next possible values for h and k? Both may be 1, 1. These are the next possible values, na? Because they will correspond to x square plus k square being equal to 2. So they will give us plus minus kx plus minus ky minus 2 pi by, isn't it? Please check. So actually these are 4 equations. If you see them clearly, they are these are the 4 equations that are contained in that one equation. Let's call them as 4, 5, 6, 7. Now let us write the point through which these lines are passing. You remember how you have been plotting the lines in your elementary classes. You were just getting the 2 points and you are joining those points in order to get the equation of line. And what was the technique to get those 2 points? By putting one of the variable equal to 0 at a time and getting the other variable. So same technique we will be using over here. If I put kx equal to 0, I will end up getting ky as minus 2 pi by. And if I put ky equal to 0, I will end up getting kx equal to minus 2 pi by. Is it? Please check. Am I right?
Yes, sir.
So kindly check, I'm writing all the points. So these will help us in plotting these lines. We will mark these points and we will join these together. And that's it. Clear? Is it clear to all?
Yes, sir. Yes, sir.
What are the next possible values of HK? X square plus k square equal to 3, obviously it is not possible. So the next possibility is one of them may be 2 and other is 0.
Yes, sir.
So with the help of this, we will be getting plus minus 2kx plus 0 ky minus 4 pi by. So this will give us kx equal to minus 2 pi by and ky arbitrary. Number 8. So 0 kx. So Arun, is there any integer value of h and k which leads to x square plus k square equal to 3? Check yourself. H and k can be integer only. Na? So none of the values, it corresponds to x square plus k square equal to. See, we have taken this. This corresponding to x square plus k square equal to 1. Then what was the next possibility? This one. And this led us to this one. And what is the next possibility now? Either 2, 0 or 2, 1. So with the help of 2, 0, you are getting 4. Now you are not getting 3. This is what I'm saying. This. Okay. We are writing the k values in the order of sum of their squares. This is the method. Clear, Arun? Is it clear, Arun? So these are the again equations of the lines corresponding to third Brillouin. I think it is enough up to third Brillouin because they are not going to ask you about the fourth or the next one because that is difficult. So in your syllabus it is up to third Brillouin only. So now I will be plotting these lines. But in order to plot, you should remember about the first Brillouin lines. Okay, so be careful. So here is the graph because it is easier to draw it on the graph paper. So that's why. So now I will be taking this as reference. Let's call it as 0, 0, and this axis as kx and this axis as ky. Okay. And let us take this one as 2 pi by a0. Then this will become 4 pi by a0. This will be minus 2 pi by a0. Minus 4 pi by a0. 0 2 pi by 0 minus 2 pi by. I think that will be enough. Now what about the first Brillouin region? One is the line k equal to pi by. It means this line. Please check everyone. Is it clear?
Yes, sir.
This line corresponds to pi by, na?
Yes, sir.
And this one corresponds to kx equal to.
Minus pi by.
There is a mistake here. This will be the point minus 2 pi by a0. This is the point. And then minus 4 pi by a0 will lie somewhere here. So this is the line. And this is the line corresponding to ky equal to pi by, and this corresponding to ky equal to minus pi by. Isn't it? Please check everyone. Let me draw this line again. Clear?
Yes, sir. Yes, sir.
You can see a square in between clearly now, which is formed by the intersection of these 4 lines. So let me tell you about these lines. This is the equation of the line ky equal to pi by. This is for ky equal to minus pi by. Similarly, this one is corresponding to kx equal to pi by, and this one is corresponding to kx equal to minus pi by. Clear?
Yes, sir.
Moving
Yes,
on to the next. Now, what were the points that we listed over there? These were the points. Huh? Let me circle these points. These 4 points were there. Please check. Is it?
Yes, sir.
Can I just zoom out this? Because it will be easier for me to draw with the help of software. Okay. Let us see, is it comfortable for you or not? Please check. Can you see this? Yes, students, please tell me.
Yes, sir.
Yes, sir.
Let's go, then I will again zoom in. Okay. I will again put it on slideshow. Because I want to draw some lines. Now. So with the help of software, it will be easier for me. Is this line visible to all?
Yes, sir.
So let me draw these lines. Because otherwise I will not be able to draw these lines. Now. Is it visible to all what I'm doing? Yes, students, please tell. Nobody speaking.
Yes, sir.
Yes, sir.
So now I will just zoom in and you will get to know. Now see, students. I think now you are able to see those 4 lines which are passing through those 4 points, and another 4 lines which are passing through minus 2 pi. So there is a mistake in this line actually, this one, but I can't help it because I was not able to draw this line on that particular line. So you can manage it, okay? You have to pass this line through this point. Please be careful.
Okay, sir.
So this line is regarding kx equal to minus 2 pi by. This line is for kx equal to 2 pi by, and this one is for ky equal to 2 pi by, and this is for ky equal to minus 2 pi by. So I have drawn all the lines that we have calculated. First, second, third, all. So is it clear? So let me mark the regions now. So this region obviously clearly belongs to first Brillouin zone, this inner one. So now I will be using different colors so that you are able to identify. Okay. And only this region, this part that I'm highlighting in blue now, that is the part of second Brillouin zone, excluding the region belonging to first Brillouin zone. So is it clear? I have highlighted the regions corresponding to first and second Brillouin zones till now. Everyone please check.
Yes, sir.
Now what about the region corresponding to third Brillouin zone now? It is very important. Third Brillouin zone. Who is going to tell me?
So the region that
Your voice is breaking, beta. Kindly type in the chat box. Voice is breaking, kindly type in the chat box somewhere. Yes, Tanya, please. Type, I'm waiting for you.
yes, sir.
Not audible, not audible. Your voice is
Writing the reason as well.
not coming, beta. Your voice is not.
Now my voice is coming.
It is coming, but only some words I am able to listen. It is breaking in between. So it will be good if you can type in the chat box, no? Because time is running. Maybe because of the internet issue, your voice is breaking. So it is good idea to type in the chat box. Not coming at all, beta.
Right.
Only this region, it belongs to third Brillouin zone that I'm highlighting right now. So I have left some part, you can see. That small square. Yes, obviously it will be outside the first and second one. The triangle. Which triangle you are talking about? They are not the triangles. Okay. You are calling them the triangles that I have highlighted in blue. Yeah, you can call them the triangular regions. Yes, definitely. You can call them the triangular regions. That is also okay. Please mute yourself. So please check everyone. Are you able to understand up to second Brillouin zone? Or is there any doubt? So now I am highlighting the region corresponding to third Brillouin zone. And for this, you need to remember one important thing. That in order to move inside the nth Brillouin zone, we can at the most cross n-1 lines. In order to go into nth Brillouin zone, please take a note of this. We can at the most cross n-1 lines. If we apply this rule to third Brillouin zone, it means in order to, when we start from origin, of course, when we start from here, in order to go into this region, we are crossing 3 lines. Now, please check. This line is intersecting 3 lines, because at this particular point, 3 lines are intersecting. So in order to reach this region, we are crossing 3 lines. And according to this rule, in order to go to third Brillouin zone, we can cross at the most 2 lines. So it means this region, it cannot belong to third Brillouin zone. It belongs to fourth Brillouin zone. Is it clear? See, how we can
Can you please
3 pi
repeat?
by. We have calculated the equation. Na? From those equations, we have drawn these Brillouin zones. We were not able to get 3 pi by. How can we extend it up to 3 pi by? What are the equations that you got? You are having plus minus 2 pi by and plus minus 2 pi by only. Na? How can you extend them up to 3 pi by? You are getting them mathematically. There is nothing like supposition, okay? Clear?
Yes, sir.
So now, what I was saying is, in order to move into nth Brillouin zone, you can cross at the most n minus 1 lines. It means for third Brillouin zone, we can cross at the most 2 lines. Now, if I include this region into third Brillouin zone, this region I'm talking about, then we are crossing 3 lines in order to reach this region. Please check. When you're moving from 0, 0 into this square, you are crossing 3 lines. This point is an intersection of 3 lines. Please check this point. 3 lines they are crossing.
Yes, sir.
But in order to move into this region, you are crossing only 2 lines. So that's why I have included only those triangular regions in the third Brillouin zone, because we are crossing only 2 lines in order to reach those regions. Whereas in order to reach those square regions that are excluded, we are crossing 3 lines. So those regions, they belong to fourth Brillouin zone, because for fourth Brillouin zone, we can cross 3 lines. Is it clear? Is it clear or not?
Yes, sir.
Yes, sir.
So now let us calculate the area of all these zones. So now what is the area of first Brillouin zone and what is the shape? Can anyone tell me?
First we need to,
It is a square first of all.
yes, sir.
Yes, sir.
What is the area? What is the side of this square? What is the side of this square?
Sir, eight.
How it is a? Look at the diagram.
2 pi by.
2 pi by. Side is 2 pi by.
Yes.
Kindly mute yourself. First Brillouin zone. It is a square with side 2 pi by, because it extends from minus pi by to pi by. So area will be side square this it is also square. The shape is also square. No? This bigger one, it is rotated one, but it is also square because the lines, they will be perpendicular. No? You can check. Second one.
Yes, sir.
And what is the side of second one? The diagonal of first one will be the side of second one. And what is the value of this diagonal? Root 2 times 2 pi by, no? Isn't it? Because side is 2 pi by and the diagonal is root 2 times side. So it is root 2 times 2 pi by, no? Is it?
Yes, sir.
So it is a square with side root 2 pi by. But what about the area?
Sir, we have to subtract the first.
What are you asking?
I am telling sir कि हमें first हटाना है.
Not able to listen. सिर्फ यही पता लगा कि आप क्या काटेंगे, बाद में नहीं आ रही वॉइस आपकी.
Sir, she is saying that we have to subtract the first area from the second one to get the.
Yeah, we have to subtract. But the shape is a square. No? What I'm saying is the shape is a square, but the area will be
Yes,
calculated.
shape will be square. That's
Yes, shape is a square, but the area will be calculated by subtracting the area of first square from second square. Area of, can I write second square? Will it be right? Area of first square, or area of square with side root 2 into 2 pi by minus area of square with side. That is also okay. So now please calculate this area and you will see that the area will come out to be same as area of first Brillouin zone. Okay?
Yes, sir.
So this will be root 2 into 2 pi by same as area of first Brillouin zone. What about third Brillouin zone? What is the side? 4 pi by, because it extends from minus 2 pi by to plus 2 pi by. What is the area? It will be area of third square minus area of second square straight away, and minus 4 times area of squares of side pi by. Those 4 squares that we have excluded, they are having side pi by. Please check. So in order to get the area of third Brillouin zone, we have to subtract the area of second square and then those 4 squares. Only then we will be getting the area of third Brillouin zone. Am I right? You have to get the area. This
yes.
So then it will be 4 pi by whole square and root 2 into 2 pi by whole square and 4 times pi by whole square. And you will find that again the area is same. So first, second, third Brillouin zone, they have same area. That is, yes, they have same area. Now, if the direct lattice, note, if the direct lattice is rectangular, then the Brillouin zones will also be rectangular in shape. And instead of 4 pi square a square, the area would be or will be 4 pi square by AB, with AB as sides of direct lattice. I think it is clear now. Please read this one and tell me if you have any doubt. Because then we would have taken the direct lattice vectors as A vector as AI cap and B vector as BJ cap. And then obviously we would have got the reciprocal lattice vectors as 2 pi by AI cap and 2 pi by BJ cap. And that would have led us to the rectangular Brillouin zone with sides 2 pi by A and 2 pi by B. And the area would have been 4 pi square by AB. Am I right? Please check. And tell me if you have any doubt. Yes. Anyone?
No doubt, sir.
Ritika, direct lattice means all those simple cubic body centered FCC. We have discussed everything in the crystal structure. No? Those are the direct lattice.
Yes, sir.
Actually, whenever you are dealing in position space X, Y, Z, they are called direct lattices. But when you start dealing with K axis, then you get reciprocal lattices. That's it. It depends upon you whether you want to deal with lambda or K. Okay. Because in reciprocal lattice also you have these shapes that we have discussed in the beginning, that the reciprocal corresponding to BCC is FCC and corresponding to FCC is BCC. So it depends upon the coordinate system or the space you are using. Okay. Clear?
Yes, sir.
Now let us discuss about effective mass. What is effective mass and how it can be calculated and why it is important to us. So now we are already aware about the motion of the free electron and the properties associated with it, that is momentum, velocity, mass, etc. But when we are having an electron inside the crystal, then these properties, they have a different meaning altogether. These are not the same as we have in case of a free electron or free particle. These are a little bit different. And why these are different? Because now we are having electron moving inside the crystal, and the crystal potential, it is acting on that electron. And the situation is exactly similar to that of particle in a box problem that we study in quantum mechanics. Have you studied that article of the particle in a box in quantum mechanics?
No, sir. Not yet.
No, sir. Yes, sir.
Nobody has studied. Some of you might have studied that article.
Yes, sir.
Okay. So even if you have not studied that article, then you can remember these things that I'm telling you. Okay. It means we are bounding the particle. Okay. We are bounding it. We are not making it free. As if you are tying a rope with the particle and you are pulling the particle with that rope. You are containing the motion of the particle. You can think it in this manner. Okay. It means the particle is not free. It cannot move according to its will. You have confined the particle within some walls like this. There are walls, and the particle, it can move within these walls. This is called particle in a box. Means you have trapped the particle in a box. Clear? So obviously it can.
You are discussing about potential well?
Yes.
Are we discussing about potential well?
Yeah, potential. You can call it potential well also.
I studied this.
Yeah. So then you should know about these wave functions and the energy eigenvalues. So the moment you confine the particle, the energy values, they become discrete. Na?
Yes, sir. They become discrete.
Discrete.
They are not continuous.
Yes. Electron is no longer free. Na?
Yeah.
Yes. So that's what I'm saying. So same is the effect of the crystal potential on the motion of the electrons. Same effect we are having. So here we are saying that the electron is moving under the effect of the crystal potential, and because the crystal potential, it is unknown to us, so we will always consider the average crystal potential. Okay. So it means the energy of the electron, it will be different from the energy of the free electron, and the momentum is also going to be different from the momentum of the free electron and everything. Clear to all this thing? Is it clear?
Yes, sir. Yes, sir.
So now, what we can do with the electron in a crystal lattice? Let me write something about this. Electron in a crystal lattice. First of all, you can write this heading. Electron in a crystal lattice. And later on, I will introduce the effective mass also. So, we already, you can write it in this manner, have an idea. This line I'm writing because I'm assuming that you have studied about this potential well. Okay? About the physical quantities. And what are those physical quantities? Such as momentum, velocity, mass, and of course energy also you can say. Energy, which are associated with a particle. So I'm considering it to be a particle in general. Particle, or you can say it is an electron. Let us write an electron only, otherwise you will get confused with an electron. So however, when an electron, because we are considering the motion of electron only, according to the heading. So when an electron, it moves in a periodic. Why it is periodic? Because crystal is periodic. Atoms are present after the regular intervals. After each a distance, an atom is present. That's why that a is lattice constant. So that crystal potential, it is being repeated after every a distance. That's why we say that it is periodic. Okay. These quantities assume a slightly different meaning. Okay. Now, what do we have for a free electron? For a free electron, energy is given by this relation, and this is equal to p square by 2m momentum, and h cross k, that is p, it is equal to 2m square root. These are the equations we are having. Please check. Please tell.
Yes, sir.
But when the electron is moving inside the crystal, then these equations, they are not satisfied. Okay, when an electron, because now the electron is no longer free. It is valid only at very high energy. Because then the electron will behave a little bit like a free electron. The instantaneous and also the potential at different positions inside the lattice, it is different. And the instantaneous potential experienced, or yes, experienced word is okay, experienced by the electron in lattice is called and this is not a constant quantity. Means it is variable. Simply, if you want to write, it is variable. It means the electron is experiencing different potential at different positions inside the lattice.
Sir, different potential arises due to which factor?
These are the atoms. Suppose electron is here near the ion. Then the potential felt by the electron is something else. And when the electron is in between two atoms, the potential will be something else. No? It cannot be same. Or will it be same, according to you?
No, sir. I just want to ask that what will means the factors which affect the crystal potential.
That's what I'm telling you with the help of diagram. Na? Potential is what? Potential is the force exerted by these ions on the electrons. Na?
Yes, sir.
So these ions are present at the regular positions. So electron can be here, or here, or here. So are you going to have same potential for the electron at all these positions?
No, sir. Different.
Different. Na? So that's why I'm saying that the instantaneous, because at any instant, the electron can be at any location inside the crystal. So the instantaneous potential experience, it is different at different locations. It means the potential is variable. So these ions, these are the source of the crystal potential. Okay, clear?
Yes, sir.
That is the reason we always consider the average potential, because it is different in different positions and it is impossible to get the potential at all the locations. It is impossible. So that's why we consider the average crystal potential all the time. And that too is not exactly known to us, even the average one. We always make the rough ideas that the potential may be of this kind or of this kind. It is like this. Okay? Clear?
Yes, sir.
Because clearly at high energies, the electron, it will not remain confined to that potential well, because the energy is very high. So it will be able to come out of that potential well. Or in other words, you can say that this electron, because it is itself having very high energy, so there will be little bit effect of the force due to these ions on this electron's motion. So it means this electron, it will behave like a free electron now. That's why these equations, they are obeyed at high energy only. Okay?
Yes, sir.
Now, can we plot this EK relation that I have listed in equation 1? This suggests that there is a parabolic relationship between E and K square, isn't it?
Yes, sir.
But that is parabolic within certain limits. Now I'm going to plot this. This is parabolic for the free electron. So now I'm plotting this relation for the actual electron inside the lattice. So electron is free only near the middle of the potential well, because when it reaches at the edge of the potential well, the electron will strike the wall and it will reverse its direction. It means for some moment the electron will stop at the wall, because before reversing its direction, the electron will stop for a while at the wall. Listen, electron is coming here. So when it strikes with the wall, it will stop here for some time and only then it will reverse its direction, because it cannot reverse its direction at once. So थोड़ी देर के लिए electron वहां पे रुकेगा ना. It means the velocity of the electron at the boundary of the Brillouin zone, it will be 0. And the boundary of the Brillouin zone, first Brillouin zone, they are minus pi by and pi by. Am I right?
Yes, sir. Yes, sir.
And how to access the velocity of the electron from this EK curve? Can anyone tell me?
So what?
Velocity is d omega by dk, na, always.
Yes, sir.
And what is omega? E by h cross.
Frequency, sir.
E is equal to h cross omega. So omega is E by h cross. Na? It means it is the slope of EK curve. The slope of EK curve, it will give us the velocity. It means the slope of this EK curve, it should be 0 at the end of the Brillouin zone. Because we have just discussed that at the edge of the Brillouin zone, the velocity of the electron is going to be 0. Please check, everyone. So you can see, I have made this line parallel to x-axis. It means the slope is completely 0. It is like this, parallel. Okay, it is like this, parallel. Slope is 0. It means velocity has become 0. Is it clear? Yes.
Yes, sir.
You can see at these points the slope is undergoing a change. Only within this region, this is parabola. And the slope is undergoing a change at these points. And these are called points of inflection in mathematical language. It is wave vector. It is wave vector simply. Na? H cross, when you write momentum as H cross K is wave vector. Na?
Yes, sir.
So these are called points of inflection at which the motion of the electron, it undergoes a change. It means when the electron, it crosses these points, it will slow down. And slowly, it will come at the rest at the edge of the Brillouin zone. Within these 2 points, the electron, it behaves like a free electron. Okay, students? Clear?
Yes, sir.
Now, moving towards the next part. So can we plot the velocity now? With all these things that we have discussed, that the velocity is going to be 0 at this point, and it is going to slow down and all. So can we? Because velocity is 0 at the 3 points here. Here also the slope is 0. And at the Brillouin zone edges. Now see. What is the shape of the curve for velocity? K vector, velocity vector. Please don't start making this graph right now. Let me draw the complete graph first. Because it is very difficult now. Sometimes. I think it is okay now. So at these points, you can see the velocity is undergoing a change. And these are the points corresponding to first Brillouin zone. This is corresponding to pi by, and this is corresponding to minus pi by. This is 0. So you can see velocity is 0 at the 3 points. And when the electron was between minus k naught and plus k naught, and after that, after crossing k naught and minus k naught, the velocity is decreasing. Please check. Okay, clear? Is it clear?
Yes, sir.
Yes, sir.
So let me write few lines on this so that you are able to remember that what is happening actually. So in the first half means 0 to pi by. So what is happening? At first the electron, the velocity of the electron, it is increasing. You can see in the figure now. It is first increasing up to k naught. Huh? And then starts decreasing after the point k naught, point of inflection or point of intersection with, you can call it, starts decreasing after the point k naught. Please check. After crossing k naught, the velocity slowly decreases and near k plus only pi by, because we are discussing first half, no? The velocity goes to 0. Okay. Similarly, we have for the curve from 0 to minus pi by. Please check. Is it clear?
Yes, sir.
You can write these lines also. The mass of an electron. So this was a strange thing about the velocity of the electron in the lattice. No? Exactly as we said in the beginning, that whenever the electron is moving inside the crystal, then these things, they have a different meaning. So we have seen that the velocity is different from the velocity of free electron. The electron is behaving totally in a different manner, as if it is totally a different particle, isn't it? Clear?
Yes, sir.
And the mass, it varies in a still more strange way. You will be shocked to see that the mass of the electron moving inside the crystal, it can be negative also. So all the values are possible. And this is unlike the mass of the real quantities that we discuss in real life. We never say that any object can have negative mass. Do we say this? Never. No? We always say that the mass is a positive quantity. And if an object is not having a mass, then it simply does not exist. Am I right?
Yes, sir.
Yes, sir.
But the strange thing is happening inside the lattice. The electron can have negative mass also. So actually, this is the meaning given to the electron because of its interaction with the crystal lattice. So in order to understand the motion of the electron inside the lattice, we are considering that the mass of the electron is varying. And why we are saying that? Now, if you are having two objects and one is moving slowly and other is moving fast, then obviously you will say that the one which is moving slow, it is having more mass as compared to the one which is moving at the faster rate, isn't it? So in order to explain the behavior of the electron, that why it is getting slow at some point and it is getting faster at other points, what we are doing is we are varying the mass of the electron. So at those points where the velocity of the electron is increasing, we say that the mass of the electron is decreasing. And at the other points where the velocity of the electron it is decreasing, we say that the mass of the electron it is increasing. That's how we are able to understand the behavior in easy manner. Because everyone knows that out of two objects, the heavier one will be having the lesser velocity as compared to the lighter one. So that way the things, they become simple. Is it clear? So tomorrow again, I will discuss about this effective mass, of course, with the mathematical expression also. Then you will be able to understand this concept in a better manner. And of course, we will be solving few numericals on this also, and then the band theory part also. So tomorrow will be the last lecture of solid state physics. Okay. Yeah, obviously, because it will be spending more time in that region, Sayali. So the probability will go up as compared to the other regions. Okay. Clear?
Yes, sir.
So that's all for today, students. So we will meet tomorrow again. Okay. Bye bye. Take care.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.